Welcome back, chemistry fans. We are going to listen to trumpet in the offing. No, we are going to talk about the 4 definitions that I shared with the class today. So let's get into those, and then you'll feel like you understand it. And you can then take the test with everyone else. You won't feel like you're out of the loop or anything. I literally spent less than 5 minutes going over these same definitions with the class. So here we go. Here are the 4 definitions. The first one is bond length. And the definition is the length of the bond. I am not trying to be snarky. That is the true definition. It's the distance in between 2 atoms. It's the bond length. The big key for it is that it gets shorter the more bonds you have. If you have single bonds, they're the longest. If you have triple bonds, they are the shortest. Then next comes the next definition, bond strength. Well, bond strength is just the opposite. It is actually stronger the shorter the bonds. So the closer they get together, the harder it is to pull them apart. The further apart they are, the easier it is to break them apart. So bond strength, the definition is the strength of the bonds. And it's the inverse relationship. Bond length gets shorter with triple bonds. Bond strength increases with triple bonds. The third definition that they covered was bond angles. And the definition is the angle of the bonds. And now specifically, it's the angle in between the central atom and one of the exterior atoms. Now, you only need to memorize 3 of these shapes down here, because the other ones are for expanded octets, which we will not be doing. So these down here do not apply to you. We will not be doing expanded octets. So please try to ignore what is behind the sort of subtly shaded regions down here at the bottom. So we've got 3 different shapes that we need to be able to distinguish and tell what their angle is. And what you would need to know is that from geometry, this is prior knowledge, you already know, a straight line, it has an angle of 180. If we were to bring that angle all the way around, the sum of all of those would be 360. So with that in mind, a circle has 360 degrees. If I were to take this trigonal planar, each one of the angles in it is divided into 3 sections. They're each 120 because that sums up to be the 360. The only weird one is what you would have expected tetrahedral to have. You would expect, if it's broken up into 4 different pieces, that it would have had 90-degree angles. In fact, it does not. It starts to move into the 3rd dimension towards you out of the paper, and the angle actually becomes 109.5. So these are just memorizations. A linear is 180. A trigonal planar is 120. A tetrahedral, as well as a bent, as well as a pyramid. All 3 of them have the exact same angle of 109 degrees. I'm not even worried about the 109.5. If you get that, that's fine. But you need to know that the angle of a tetrahedral, of a bent, and of a trigonal pyramid is 109. Okay, last definition is this new term called resonance. Resonance is whenever there is fluctuations or there is variance in the appearance. So the example that I used is if you have a stringed instrument and you strum it or you pluck it, it vibrates and it appears to be in 2 different locations. Whenever you pluck it, this string appears to be in 2 different locations at the same time. So if this were some kind of a guitar, although that looks just like a avocado, I think. But if you were to take some kind of a stringed instrument and you were to pluck the string, it would fluctuate, it would vibrate in between 2 different places, 1 and 2, but it would look like it's in the same place. It's filling up that whole position. Well, in chemistry, resonance just means that I'm going to move my double bonds, or it could be a triple bond, but I'm going to move it to a different location. There's 3 different locations this double bond could be. It could be in position 1, 2, or 3, but notice It moved to position 2 in a second way that you could draw it. It moved to position 3 in the third way we could draw it. All three of these are correct Lewis structures. And so they call this phenomena where there's multiple possible correct Lewis structures, they call this resonance, because it's fluctuating between all three of these possible Lewis structures at the same time. The double bonds are moving in between the positions. This is everything that I covered with the class, and I covered it just about as surface level as what I'm doing with you right now. So you have 4 new definitions. That is not much to ask of you to try and be prepared for the test tomorrow. If you feel like it's too much of a burden, we'll figure out some time that that you can take the test later if that's what you need to happen. So talk to you soon. Thank you so much for staying with me. Bye-bye.